Hello, I am Dawn Bolrus, and I'm an instructor for GBS 221 Business Statistics, and I'm going to be using this forum for recording information and demonstrating key concepts throughout the course. As part of these recordings, I will also demonstrate use of tools such as Excel and TI 8384 calculator use for some of the key things. I'll talk also about key concepts that are critical for understanding in each chapter in order to make sure that when you move forward into future chapters, you've understood the key concepts necessary that get pulled together in later chapters. In this recording, it will be about descriptive statistics, and that specifically being graphical and numerical measures of describing data. Most statistics books start with the first chapter describing what data is and talking about some key definitions. In statistics, understanding definitions is critical. Statistics is a course, even though math-oriented, it is much more theoretical in nature, and therefore understanding concepts, understanding definitions, understanding the data notation become critical in the course. After the usual just understanding data and some definitions in the first chapter, then most texts and courses of statistics will start out with a chapter on graphical measures, graphing data to try and help summarize it, and key concepts about graphing and graphical statistics, as well as then a chapter on numerical measures. For our particular class, we have graphing in Chapter 2 and numerical measures in Chapter 3, and so that's what this recording will be focused on. I'm going to start with looking at Excel as one of our tools. For a business statistics class, Excel is the key tool that is used. However, you will also be responsible to be able to understand formulas and use them in a calculator for exams, as you won't have access to Excel on exams. So it is important to understand both how to use Excel as a tool, but also how to use a calculator as a tool to be able to work any problems in the course. The reason Excel is the primary tool is that in a business environment, most business analysts or business professionals are sitting at their computer and have Excel at their fingertips, and they don't necessarily always have their TI calculator at their fingertips, which is why Excel is so predominant in this particular course. I will again be demonstrating both, and I will in this particular recording as well. I'm going to start by describing some things within Excel that will help make these first few chapters much easier. Excel has a feature that includes data analysis and statistical analysis. There are lots of software packages. In fact, our Cengage publisher has tools called Stat Tools. Other publishers have PHStat for Prentice Hall, MyStatLab, StatCrunch. Those are all different tools that different publishers have to help with particular courses. Stat Tools is very beneficial and is available for the particular course that I teach, but Excel is also available, and Excel, as long as you have a licensed copy of Excel, what I'm going to show with the data analysis tool, there will not be any need for additional purchase or anything other than just activating the actual tool. The data analysis tool portion of Excel comes with licensed Excel, but it just isn't an active application. It's what's known as an add-in, but it is embedded within the files on the computers and installed with the basic Excel. For Mac users, if you have a student version of Excel, it may or may not have the add-in available to be installed. I've found students who've been able to find it and students who haven't. I don't use a Mac, and so if you have a Mac, my suggestion is to use Excel Help and search on add-ins or data analysis, because that's what we're going to actually be doing. I'm going to actually demonstrate the activation process for the data analysis add-in tool by looking at both Excel 2013 and Excel 2007 to show that it's slightly different but almost identical. So So I'm first going to show 2013, which is currently on my screen. And in this, if you notice on this main menu, under the Data tab, that's where we're going to be looking for the Data Analysis tool. And so if I click on the Data Analysis or the Data tab, at the end, over on the far right, I do not have anything that says Data Analysis. That tells me it's not currently active on this particular Excel application. I only need to activate it once, and every time I open up Excel, it will be there. So the process I'm going to show you only needs to be done once. In this version of 2013, in order to activate it, you simply go into File and click down towards the bottom where it says Options, and it opens up a new window. In that window, you're looking for add-ins, and notice under here it shows active applications and inactive applications. These are applications that are part of Excel, but they're just not active on this particular version of Excel right now. The ones we're looking for are Analysis Toolpak or Analysis Toolpak VBA, and we're going to actually activate both of them. If they didn't both show here, all I need is one of them to show, and I just click on one of them, and then I must click Go. You can't go straight to OK. You must hit Go in order for it to open up the dialog box that allows us to activate it. And then the dialog box is just where it's just toggles. You click a check mark and put a check mark in front of Analysis Toolpak as well as Analysis Toolpak VBA. And then when we hit OK now, as soon as we go to that Data Analysis tab, it will now show under the Data tab, the Data Analysis tool. And this is the tool that I'm talking about. And this is discussed in the textbook, the Cengage textbook. It's discussed on page 131 in Chapter 3 under the Descriptive Statistics Summary tool. And in the Appendix E on page 1014 and 1015, there is it talks about actually how to do this activation process that I'm doing right now. So that's with 2013. So now I'm going to actually go ahead and now demonstrate using 2007. I actually have two computers here set up side by side that allow me to look at things in two different ways. So I'm going to actually be doing that. So 1 second here. All right, so now I'm ready to open up the other version of Excel. Okay, this is Excel 2007. Here, rather than using the File menu, we use the Office button here. It's still, I'm showing here the Data tab, and then this Data tab, again, there is nothing here that says Data Analysis, and that's why I know it's not active on this particular system either. So again, I click on that Office button, and again, rather than it being down through this left-hand list of items, it shows here under Excel Options. So click on that, and it brings up that same menu system where it shows add-ins, and now it's the same. Here's the Analysis Toolpak, Analysis Toolpak VBA. Once again, click on Analysis Toolpak and Go. Don't try to go straight to OK. And again, I'm activating Analysis Toolpak VBA, and hitting OK. And once I've done it, the Data Analysis tab is now open and available to me. And what I will show just for a second, as soon as I click on that, it brings up dialog boxes, and this is what we're going to be talking about here in just a minute. Okay, so for Chapter 2 and Chapter 3, there are some very significant benefits to using the Data Analysis tool to do some of your homework and to work through some of the different topics within those chapters on either descriptive summaries or in graphical natures or in numerical natures. Okay, so the next thing I'm going to do is actually demonstrate using the Data Analysis tool in order to actually solve some problems and create a histogram, as well as calculate means, medians, modes, standard deviations, those things. so the next thing I'm going to open is I'm actually going to go in and open up some problems and show some different ways in which we can actually solve these. Okay, so I'm going to, at this point, open up Cengage. This is for my Cengage students for my classes, where we're actually doing things, Cengage tool for our homework. So I'm going to start first with Chapter 3. Again, Chapter 1 is, for our course, is focused on more definitions and understanding things. Chapter 2 is focused on frequency distributions and graphing, and Chapter 3 is focused on describing with numerical measures. But I'm going to first open up Chapter 3 with numerical measures. So I'm going to go in to Chapter 3, and I'm going to actually open up a couple of homework problems. Now in this case here, we have data, 5 numbers, and it's just asking to calculate a mean and a median with this set of 5 numbers. I could easily go into Excel and simply type those numbers in a column straight down, and that would allow me to use the data analysis tool. I'm going to also show you, so actually let's demonstrate with this problem. 10, 20, 12, 17, and 16. 10, 20, 12, 17, and 16. Within Excel, there are lots of functions, and in particular, the function average is a mean. And so within our textbook, a lot of the reading and chapters are going to talk about just functions where you can just type, and I'm just going to list here, so this would be the average, and this would be the standard deviation. In Chapter 3, they're going to talk about populations versus samples, and for right now, I'm going to do it using population, and then I'm going to do it also to show standard deviation, assuming a sample. Just to show that they are different. And you'll see that also on the formula sheet when I look at that in a second. Okay, so the function for average is simply to set off any function in Excel. It's just equals, and I can just type A of average. One of the things that's nice about Excel is you can just, as soon as you start typing a function name, it gives you a list of them. If you double click on the one you want, then it will tell you what you need. And here it just says, I need to have the numbers. So all I have to do is just highlight the range of numbers, hit enter, and it tells me that the average of that data set is 15. I can do equals ST and start off standard, and notice there's a standard deviation .p and standard deviation. Some will have standard deviation STDEV.S, STVEDEP.p. The S is actually for the sample, and notice this one here says estimates it based on a sample. In Chapter 3, the definition of sample versus population is essential. So right now I'm trying to do population, so I'm going to do this one. And again, it just wants those numbers, and so if I just highlight that, hit enter, the standard deviation of the population is 3.58. And in this case, I'm going to do the STD, this one here, again, highlighting the range, and it tells me that the sample, if that was a sample of data, the standard deviation is 4. One thing to note, and this is important especially for digital tools, even though Excel may show only these, sometimes it's important to make sure that Excel hasn't truncated the data, because they may want to 3 decimals, and it may have assumed since everything was to 2, it just shows it to 2. So oftentimes you may want to actually go in through the home button and through these here where it shows the arrow moving zeros in both directions to increase or decrease number of decimals, just to make sure you have it. My recommendation for any digital tool, if they ask for something to 2 decimals, carry every calculation to 4 decimals. Always carry 2 decimal places past the longest decimal requirement of a problem, to make sure that you're not bringing in additional rounding error. Now I just want you to pay attention to these numbers because I'm going to show you how to calculate these numbers using a TI calculator to do it. And so give me just a second because again I have to change which computers because I have a screen that will allow me to do it. Okay, so this is, in that last one, I'm just going to show how to use the TI calculator, and this one happens to be a TI 84 Plus screen. And so what you are going to want to do is, once it's turned on, clear it, under this button that says Stat, S-T-A-T, if you click there, there is this Edit menu, Calc menu, and Test menu. In the second half of any statistics class, that is all about confidence intervals and hypothesis tests, and that's all here underneath this test button. But oftentimes you have to actually insert data into a list in order to calculate anything. So we're going to go in, and that's under the Edit field. And then one variable statistics will be under the calculation. So again, it was the Stat button, Edit, and once I've clicked Enter here, I can go in, and these are just lists of data. Now, if there's already data in your calculator, you simply, to clear, you can go and click at the top, but in my case, because I'm doing this as an emulator, I have to actually move arrow buttons, but you could move yourself up into this area. When you're in the top, under the list name, you can hit Clear, Enter, and it clears out that list. So again, that was moving it up to the top, hitting Clear, and Enter to clear out the list. Then I can go in, and in order to run one variable statistics to calculate mean, median, mode, standard deviation, I need the data under the list. List 1 is the default, so we need to put it into list 1. And so to do that, I simply move into here, and our numbers were 10, hopefully I remember these, 10, 20, pull up to remember what they were, 12, 17, and 16. Okay, 17 and 16. Once you have your data in list 1, then you can tell the calculator to calculate it. The way we do that is, again, that Stat button, only now it's going to be under Calc, so we just need to go over to Calc. One variable statistics will calculate means, median, modes, quartiles, ranges, and so I just hit Enter, and it assumes list 1, and it requires me to hit Enter again to say, yes, I want it under the default. This X bar is the mean, 15, which we already showed in Excel. These are just some of the calculations that are part of going into it. It added up all of the X values, or it added up all the squared X values. Then notice it has SX and this symbol sigma X. This is a Greek symbol, and we'll talk more about that in a little bit. SX is the standard deviation of the sample. That was the 4 that we calculated in Excel, and here's the standard deviation if it was a population, the 3.58. And I'll show you in the formula sheet why the standard deviation is different, whether it's a sample versus a population. But this can calculate this. Then notice that there are other things. This arrow says there's more information down, and it says that the minimum of that data set was 10, the maximum was 20, and then we have our first quartile and third quartile. I will let my students know that quartiles on the calculator are not necessarily going to give you the same answer as quartiles in Excel. The function in Excel is an equals quartile, and you'll see it's follow the textbook, but it's equals quartile in order to be able to calculate it. So make sure that you're using the proper functions for doing the homework. Quartiles are one of the ones that it's intended to be an approximation of where 25% of the data lies below the Q1, the first quartile. About 75% of the data lies below the third quartile. So it equates to also percentiles. But there are different mathematical formulas that different software packages, calculators, Excel even has multiple versions, different formulas that it uses, and textbooks use different versions. So be sure to look within your own textbook to make sure that you're following the right process in order to calculate a quartile. That can be one of the areas of frustration in doing any type of digital homework problem on quartiles. So that's one of the ways of using your Excel calculator, your TI calculator to be able to run descriptive statistics using the numerical measures of mean, median, mode, deviation, some of the most frequent ones. And that will be beneficial on exams. Okay, let's exit out of this. And we're going to go into a more complicated problem showing how to use Excel in the data analysis tool specifically. Okay, so now I'm going to go back into Excel. Some of the problems will give you the data this way, and again, you can enter them into whichever tools, but some of the problems will actually give you a data file. For example, here's one that shows you the data, and you can open it up, and it has the data embedded there. Sometimes it will show it as a web file link. And this one's showing just data file. I think the next one that I'm going to do as an example will show it as a web file link. But let's look at this one here. When you click on the data file, and I'm right-clicking on this, it may open up Excel directly, or it may actually open up a file for download. And so in this case, I just want to open up the file for download. And it will go in and embed it within my Excel. Now notice what some of the questions are here is it's asking for a mean, a median, a mode, quartiles, and such. So I can go into the Excel file it has downloaded and put it in from that file. Now in this case, the actual data is in two sets of areas. It's columns A and B, and also C and D. That was just because they wanted to make it easier to show on the screen and things like that. In this case, I want everything in a column. So I'm going to actually take this area and do a cut right click to get rid of that and actually paste it into here. And by doing that, it just enables me to have all of my data. There was 10 colleges shown, and it's going from rows 2 through 11. In this case, I'm going to actually show you how to use the data analysis tool that we added into Activated. So here I'm going to go into data analysis tool. So I just click on data analysis tool. And the chapter 3, descriptive statistics calculations, is under descriptive statistics. The chapter 2 graphing capabilities are going to be under histogram, but for right now we're going to look at descriptive statistics. I'm going to click on OK. These dialog boxes within the data analysis tool are very similar. They'll want to know where is the data located, that's the input range, and then where do you want your results to go, and then what is it that you want. In this case, we want to input our range. If I was to highlight the entire range of endowments, including the title, then I would click on this that says label in the first row so that it doesn't try and do a calculation on these words. I find that it's better to generally not include the title, and I'll show you why in the next chapter when I'm looking at the chapter 2. So my input range is just the actual data, and I don't click on this. If I clicked on this, it would assume that that 7.2 is my header, and it would not calculate it, and it would say that I only had a count of 9 endowments that it was calculating on. So I'm going to not have that. I'm going to just put it in a new worksheet. It will just create a new worksheet down here where it will put the data. And what I'm looking for in this is the summary statistics. So I'm just going to really just, where did the data come from? It's right here. It goes to a new worksheet, and I want summary statistics. I click OK, and here is the new worksheet tab. And I'm just going to show that the widen this column so you can see what it is. It calculated the mean of this data, the standard error, which we'll talk about in following chapters, more after like about chapter 6, 7. The median, the mode, the range, the standard deviation. In the data analysis tool, it always assumes sample standard deviation for this. So for that last problem, it would have been the 4 rather than the 3.5. Showing you the minimum, the maximum number, and notice the count is 10. For my courses, whenever I assign projects, I require this table in its entirety, including kurtosis and skewness and all of the things that you may or may not be using from this table, because I know where these calculations came from, and my projects are intended for you to be describing to me that you understand what the information is telling you. And therefore, this is a requirement that you must do. If you do not have access to this data analysis, or you can't get it installed in your version of Excel, then you need to contact me so that we can discuss how to make sure that you can get it. But this will be a requirement for both the projects that I assign in my courses. You must have this data analysis table. Okay, so that's the data analysis table, and from that you can then very easily go in and answer questions. So for some reason it looks like the Excel version did not actually show, so I'm going to go in and show it one more time, because for some reason on the screen I don't always see when the screen disappears on me. So let me open up Excel again. Alright, so this was actually the table that I created. Why it did not, I don't know, but we're going to go back to the data. It came in the 2 columns, and I simply cut from these columns and pasted it below this so I would have all of the data in a single column. Then I went into data analysis, descriptive statistics, okay. I input the range. Again, I'm not sure where my audio recording, where my screen messed up, so that's why I'm re-showing it again. Highlight the range here. Tell it where to put it. It will just create a new worksheet down here if I do that, or I can tell it exactly where I want it located. Just make sure you check summary statistics and make sure you know whether or not to have the label in the first row. In this case, I do. I only started with row 2, so that is not the label, so I do not want this checked. If I started with row 1, I would check this so that it would know not to count that as part of its calculating. I hit OK, and it creates this new worksheet. And just again to show, there's the mean, the median, the mode, range, standard deviation. This is the table I require on projects. Again, very easy to run calculations through that. Okay. Now I'm going to go in and show you some things from the graphical versions, and that is how to use Excel to actually create graphs. So I'm going to exit out of this. Now that data analysis table did not give quartiles. So again, for any of these questions that are asking for quartiles, you will need to just use the equal quartile function. And I will send out a message to my students specifically on using quartiles and the issues within Excel as to which equation or which quartile function to use to operate best with Cengage. Okay, so now I'm going to go actually in and go into the Chapter 2 assignments. And I'm going to show you some problems that are required for doing frequencies. Within our graphical measures are tables as well as graphs. In the tables, some of the key elements about tables will be frequencies, relative frequencies, cumulative frequencies, percent frequencies, and so there are actually 6 different types of frequency columns and data tables that you are responsible for. You are responsible for a frequency, a cumulative frequency, relative frequency, cumulative relative frequency, percent frequency, and cumulative percent frequency. And I'll show that with one of the ones that I'm going to look at. Okay, so the problem I'm going to look at here is going to be question number 6. Again, this is a different way that the Cengage can give us our data. When it says web file, it is also connected directly to Excel, and we can click on this web file and again open up that in our Excel. And in this case, they're looking for some information such as highest price, lowest price, and then they want the frequency. Now, this could have just as easily asked for frequency, relative frequency, cumulative frequency, percent frequency, cumulative percent frequency, cumulative relative frequency, and again, I'll show you how to do that within here. What's important here is that they're asking you to create the frequency in these different groupings. And these groupings, or these different ranges of data, can be called bins. Excel calls them bins. That's what we're going to be looking for when we use the data analysis tool. I have called them buckets, groupings, classes. It doesn't matter. The textbook actually calls them classes, but whether you call them classes, bins, buckets, groupings, they're just these different groupings. One of the keys to frequency distributions is if it's numerical data, these groupings must be the same width. Notice these are all 10 wide. I'll expect to see things with pretty numbers to where doing things by 5s or 10s or 25s will make more sense. So we'll look at that in a second. But in this case, here are our groupings. Excel wants to know the upper limit of each of the groupings. So Excel is going to be looking for 19, 29, 39. What are these bins? Now, this data for this particular problem has none of the numbers have any, they're only just in dollars. They're not in dollars and cents. Therefore, there is nothing between 19 and 20. The data either has a 19 and a 20, or it has a 29 or 30, but nothing with cents after it. We need to make sure all of the data range is covered. It's okay or acceptable to show this with these groupings where the range from 19 to 20 is not covered because the data does not include it. Otherwise, we might want to show this as 10 up to $20, 20 up to $30, 30 up to $40, and maybe we might show them as $19.99 or $29.99 or $39.99. But because there is no data with cents, we can just show them as those ranges, and that's fine. Okay, so let's go in and look at the data that it created when we went in and created our data file. This is the actual data file. Again, the dollars per share, just in a very large column of data. So once again, I'm going to go into data analysis, and I'm going to use the histogram feature in this time. Now, the textbook that we use talks about pivot tables, and those pivot tables I find to be much more complicated than just using the data analysis tool to create my histogram. So you're welcome to use whichever, but you will be required to create histograms and show them, because again, for the project, you must create a histogram. And this histogram that we're going to do will actually create both the histogram as well as the frequency distribution. Okay, so I'm going to be doing the histogram for this. I'm going to click OK. Now, it asks for the input range and the bin range. Well, the input range is the raw data. The bin range we have to actually show on here. So I'm going to close out of this and put the bin range in here first. So you can do that anywhere within the spreadsheet. Just create an area that says bin. And again, these are those upper limits. So in this case, it was 19, 29, 39, 49, 59, 69, 79, 89, 99. Oops, that's not the way I want to do it. Sorry about that. Not paying attention. 19, 29, 39, 49, 59, 69, 79, 89, 99, 109. Okay. Once we've done that, now we have what Excel needs to be able to do it. We need to know the data and what the upper limits are. And in this case, we want upper limits of this. So we're going to do data analysis, histogram, OK. The input range, again, I'm not highlighting the header again. And the reason for this, specifically, and why I said I tend not to use the header, is because in this case I need both the input range of the raw data as well as the bin range. If I showed from row 1 here where I included the label, I would have to include a label above this. You have to be consistent. So I find it easier just to do just the data alone and just be consistent and not have them include labels and not click on labels. So my raw data is in column B from 2 to 31, and my bins, my upper limits, are in column D from 2 to 11. Then again, it will just put it in a new worksheet, only this time I want to say give me chart output. This will create a base chart as well as the frequency distribution. So I'm just going to click OK. It opens up and shows me the spreadsheet where it creates the data. Here's my basic chart. I have a little bit of cleanup to do on this, but it also shows me the basics of this. Now what I'm going to do first is I'm just going to kind of move this histogram over, because you can easily, if I needed cumulative frequency, I could easily create a column that says cum frequency. And then I could go in and create one that says relative frequency. And I could do, again, relative, cumulative frequency. And these are the ones that you are required to know. I could create one that says percent frequency and cumulative percent. Frequency is simply the count. Notice it created this more category. As long as this data is 0 in the more category, I've included all of my data, and I can simply highlight this row and delete it. Now notice there's a more column over here on my graph. When I delete this row, and I'm just right-clicking on the row, and I can delete that, and notice it disappeared from my graph as well. The other thing I can do is, if I want to show these as this really is the 10 to 19 grouping, so I'm going to just show it as 10 to 19, and since it might think that that's doing subtraction, what I really want to do is put an apostrophe in front of it saying that's a label, and notice on my graph it changed from 10 to 19, so I can have this. Now, one of the things that is essential in histograms versus bar charts, when you read the chapter, is histograms do not have gaps between the bars because we encompass all of the data range here. And so the way we're going to eliminate those gaps, and this is talked about also in the textbook under the pivot table section, it talks about how to clean up the graph that you create, and also how you could use the charting function within Excel, which is under Insert, Charts, Bar Charts, and how you could create this. But again, the data analysis tool creates the first one. But the cleanup is still necessary, and that is you just move your cursor over a bar, right-click on it while you're there, and under Format Data Series, there is this gap width, and we simply need to pull that gap width to 0. And close it, and notice the bars are now all connected. These two groupings, the 89, 99, is because there were no data points in those bins or those buckets or those classes. That is valid blanks. It's not a gap between the bars. Other things that you can do is to make this graph look better is to simply click on the graph anywhere, and you can actually stretch it to make it look more meaningful. Now I can actually see where the different data is, and I can look at shape and see that it's skewed right. The skew direction is where the tail goes. If you're thinking of a dinosaur, it's where it stretches out. So in this case, it's skewed right or positive because that's where the tail is down over in here. For some reason, my mouse is not moving properly. Okay, so this is where our tail is. So this would be a right skew or a positive skew. Okay, so again, I could create these other columns. A cumulative frequency simply just says take the first number and accumulate as you go down. So we would actually have this be 5, and then this one would be 5 plus 10, which would be 15, and this would be 15 plus 3, which is 18, plus 2 is 20. And you could also do plus the next cell. So you can use functions or formulas to do that. And then 28. And then when we get down here, we get to 29. And then we add 0. It remains at 29. It remains at 29. And then it goes to 30. The final number in a cumulative frequency will be the actual total count if I was to do a summation on column 1 as the frequency. This total column will total up to 30, and the cumulative frequency will end at the cumulative amount. A relative frequency is simply a percent but expressed as a decimal. So what you're going to see is that the numbers you would have in the relative frequency column and in the percent frequency column would be the same, except this will be expressed as a decimal, this will be expressed as a percentage. So in the relative frequency, it is just what is the percentage that this grouping has of the total, and so it would be 5 out of 30. So you would simply do equals 5 divided by 30. So we could just go in and do equals 5 divided by 30, or equal that cell divided by the total, and in this case the equal 10 divided by 30, or 1/3. The relative cumulative would again do the same thing. This one would be the 16%, or the 0.16. This would be the 0.33. The percent frequency is the same as a relative but expressed as a percent, so this decimal means that it's actually 16.67%. So you could actually just take this value times 100, and this one would actually be expressed as 16.66667. And this would be then again the 33 point, sorry, not 333, but 33.3333. So I still did that wrong, 33. Or I could just take this value times 100 and it will give me that number. Again, relative cumulative, simply adding it up. The sum, the total, the last value in the relative cumulative will be 1. The total of the relative frequency will be 1. The bottom of the relative frequency, the sum total, will be 100 because it will add up to 100%. And the cumulative percent last number will be 100. So those are just ones that you need to know. Most of the things that you need to understand from this chapter about graphing is understanding shape, understanding these frequency distributions and these percents and relatives, because they're going to come into play when we talk about probabilities later on. These end up representing probabilities, and so it becomes very important to understand the concepts of frequency distributions, shape, and histograms now. Bar graphs with gaps, if it was not numerical data here, if we had words, categories, maybe reasons for tardy to work, and different reason categories, then you would just have reason categories down here, and it would simply be a bar graph, not a histogram, because we would not be calculating averages on those reasons. So important to understand that data is what's behind this. This column of data here as frequency is not the actual data. The actual data is where the data came from. It was the actual pricing information per share. If it was the company name as the data, this would be categorical data, and this is the data. So just because we summarize it into a table and can create summary information from it, such as the graph or the histograms or things like that, does not mean that that is the actual data. The data is what is behind in all of those things. Okay? So that is using the data analysis tool to create calculations of our numerical measures and in creating the graphs. Again, I find that the histogram feature within the data analysis tool to be much easier than using pivot tables to actually graph things. The last thing I'm going to just show is just going to be under our Canvas tool for our course, and that is within Canvas, everything is organized in modules, except that with the course projects, I have defined them in a single module so that they're very easily found and understood. Then I have the different chapters that are within here. Within every chapter, you'll see there is a formula sheet. That is the formula sheet that will be used for the exams for that group of chapters. So chapters 1 through 4 will be on our first exam, and I have a formula sheet for chapters 1 through 4. And that's embedded within the chapter 1 through 4, as well as in each of those chapters 1 through 4. So, sorry, it closed me out of here, so I need to go back in here. Okay, so I can open up that document. You can download these. Again, this is what you will be given on the exam, so using it now while you're doing homework will be very beneficial to you. Notice there is nothing for chapter 1 because it was mainly definitions. For chapter 2, we have frequency, relative frequency as just how many are in that grouping divided by the total number, and percent obviously expressed as a percent. The two formulas that are here are ones, this is not in the book, the 2 to the c greater than or equal to n. This is the minimum number of classes necessary. And therefore, if you had 30 data points, you don't want to have 30 bins or 30 buckets or have every single data point in its own grouping. You want to create a histogram or a frequency distribution by grouping and bucketing the data. And so this would be the minimum number of classes. And therefore, if you had 4 classes, 2 to the c, that means 2 to the 4th, would be 2 times 2, which is 4, times 2, which is 8, times 2 is 16. Well, 2 to the 4th, 4 classes is not enough because 16 is not greater than 30. But if I did that to the 5th, 2 to the 5th is 16 times 2 is 32, and that is. So 5 would be the minimum number of groupings, minimum number of classes that I would need for a data size of 30. This is just a rule of thumb. It's the minimum number, so you could do 5 or 6. You don't probably want to do 7 or more. Again, you want to stay to the lower side, but at least 2 to the c. The width that you create would then be, well, what's the range of the data and how many classes do you want to do it? So the minimum width that each of those classes would have, if you had data that ranged 100 units and you wanted 5 groupings, then 100 divided by 5 would be 20, and that says you need at least 20. But maybe you want to use 25 because it makes the data prettier. If this class width came out as a minimum class width of 4.72, I would do it as groupings of 5 and start maybe a little lower. I wouldn't start with the lowest number. I might start with, instead of starting with 8, I might start with 5 and do 5, 10, 15, 20. So just understand that there's no real correct answer in these, just general rules that say we need minimum class width determined by this formula and the minimum number of classes determined by this formula. Those will be tested on my exams. In Chapter 3, it's primarily formulas for those numerical measures, the mean, the median, the range, the standard deviation, and variance. Be careful and watch symbols. Symbols are essential in this class. Population is different than sample. Population tends to be Greek symbols. This is the Greek S, the smaller lowercase s, sigma. The capital Greek S is actually this symbol right here embedded in the formula, which capital sigma means sum, add up. But this is a small sigma, so oftentimes you'll see this in things. This is the Greek mu, meaning average. Looks like a U, it's not, it's a mu, it's a Greek M. X bar is just the sample, it's our letter X, but a bar over the top means the average of the X's. Our letters S is for a sample. So again, Greek letters for populations, Arabic or our letters for samples. Notice in the calculation for mean, it's just add up the values and divide by the number of values. You're not going to notice a difference between the sample or the population. However, when you calculate standard deviation, you will notice, because in this case you divide by the number of data points. In this case, you divide by the number of data points minus 1. That was why sigma sub x came out different than sx in the calculator and in Excel. One came out as 4 on the first problem I did, and one came out as 3.5 something, because the sample has error and therefore will always give a wider standard deviation than a population calculation. That's why it's essential to know which calculation you are using and which formula you're using. So it's essential to understand whether you're looking at data that came from a sample or data that came from a population. Okay? So that's the keys for chapters 2 and 3, graphical and numerical measures of data and descriptive statistics. Okay, so I'm going to close with that. And I will see you on the next recording.